Very good evening, class 12th. Continuing with the unit 8, your D and F block of elements. This chapter I said I'll be doing it in 3 parts. The part number 3, dealing with the lanthanoids and actinoids, has already been done. We are left with part 1 and part 2. In today's class I am going to talk about the part 2. That is these common oxidizing agents, potassium permanganate and potassium dichromate. This involves manganese, a D block element. This involves chromium, a D block element. And these two are important compounds of the D and F block of elements chapter. So continuing with these two, I would be beginning with potassium dichromate, the orange colored crystals that you have in your labs, and potassium permanganate, everybody knows you utilize in titration. Beginning with the preparation of the potassium dichromate. Now it is a 3-step process. The first step involves your chromite ore. It is fused with sodium carbonate and oxygen gas. Fused का मतलब कोई पानी नहीं, only heating your ore with sodium carbonate and oxygen. It leads to the formation of sodium chromate. बेटा एक Cr है ना, so we call it as chromate. जब 2 Cr होते हैं, we call it as a dichromate. फेरिक ऑक्साइड एंड CO2. CO2 इज द गैस, तो ये तो निकल जाएगा. अब बचा ये दो. आफ्टर द रिएक्शन इज डन, वी ऐड वाटर टू इट. वाटर डालने से क्या होगा? दिस विल डिजॉल्व एंड दिस विल नॉट. सो दिस कैन बी फिल्टर्ड using a filter paper. So your Fe2O3 is removed and you are left with your sodium chromate. Second step में क्या करना है? Acidification. When sodium chromate is acidified, it transforms into sodium dichromate. Now, sodium dichromate क्यों बनाया है? हमको तो potassium dichromate चाहिए था ना. हम पहले sodium dichromate बनाते हैं, उसके बाद we have a double displacement reaction where your sodium dichromate is reacted with KCl. There is an interchange of ions. Sodium gets a chloride. This is highly soluble, goes into solution. This is less soluble, so it crystallizes. So it can be easily separated. Now, this is the final term. एक important बात क्या है? Why do we do it indirectly? शुरू में ही पोटेशियम कार्बोनेट ले सकते थे ना, बट वी टेक सोडियम कार्बोनेट. पहले सोडियम का क्रोमेट, फिर सोडियम का डाइक्रोमेट, फिर पोटेशियम का डाइक्रोमेट. क्यों? द रीजन इज सोडियम सॉल्ट्स आर हाईली सॉल्युबल एज कंपेयर टू पोटेशियम सॉल्ट्स. तो क्या हुआ? फ्रॉम द क्रोमाइट ओर, क्रोमियम इज एक्सट्रैक्टेड आउट मैक्सिमम बाय यूजिंग सोडियम कार्बोनेट, so that maximum of chromium from the chromite ore is leached out, is removed in the form of sodium chromate which is soluble in water. तो आपने इसमें से ओर में से मैक्सिमम क्रोमियम निकाल लिया. क्रोमियम निकालने के बाद उसको डाइक्रोमेट बना लिया. डाइक्रोमेट के बाद अगेन देयर इज अ डिस्प्लेसमेंट रिएक्शन वेयर यू हैव पोटेशियम सॉल्ट कम सॉल्युबल होता है, सोडियम गोज इनटू सॉल्यूशन एंड यू हैव crystals of potassium dichromate with you. So the reason for making potassium dichromate in 2 steps is higher solubility of sodium chromate so as to extract out maximum chromium from the chromite ore. Now this is your CrO4 2- called as the chromate ion. This is a yellow colored salt and this is your Cr2O7 2-. It is called a dichromate ion, orange color. क्रोमेट को डाइक्रोमेट आसानी से बनाया जा सकता है बाय एडिंग एसिड टू इट, या फिर इफ़ यू डिक्रीज द pH. पर अगर आपको डाइक्रोमेट को क्रोमेट बनाना है तो यू नीड टू ऐड अ बेस टू इट, या फिर pH कैन बी इंक्रीज्ड. ये बहुत बार बोर्ड का क्वेश्चन रहा है. हाउ कैन यू ट्रांसफॉर्म अ क्रोमेट टू अ डाइक्रोमेट, और एल्स व्हाट इज द इफेक्ट ऑफ pH ऑन द क्रोमेट एंड डाइक्रोमेट आयंस. So if you decrease the pH, your yellow solution would go into a orange solution, and if you add base to an orange solution, it will go back to the yellow solution. Fine. Now there's an important fact about dichromate. Why is this an oxidizing agent? The reason lies in this weak CrO-Cr bond is weak. Can you see this? इसका बॉन्ड लेंथ 179 पिकोमीटर्स है, बाकी सबका बॉन्ड लेंथ 163 पिकोमीटर्स है, विच मीन्स दिस इज अ लॉन्गर बॉन्ड. बॉन्ड अगर लॉन्गर होता है तो बॉन्ड वीकर होता है, विच मीन्स दिस कैन ईजिली ब्रेक, and if it breaks you will easily get your oxygen and hence it acts as an oxidizing agent because of the weak CrOCr bond. Question पूछने का क्या तरीका होता है? What is the oxidation state of chromium in CrO4 2 minus? The oxidation state is +6. What is the oxidation state of chromium in dichromate? Again it is +6. Which is a better oxidizing agent? It is not because of oxidation number. It is because of the structure, because of the bond which is weak, easily gives you oxygen and acts as a better oxidizing agent. Fine? Now, potassium dichromate is a strong oxidizing agent in acidic medium and it is used in leather industry. Now, to give you a chemical proof for this, you have your dichromate ion in acidic medium transforms into chromium 3 positive ion. Now let us balance this redox reaction. 2 chromium है तो पहले chromium को 2 कर देते हैं. The second step is balance oxygen by means of water. 7 oxygens है तो 7 H2O. The third step is balance hydrogen by means of H positive. 14 H है इस तरफ, so 14 H positive. Left is electrons. How many? What the charge? The charge can be balanced with by means of electrons. यहाँ पे कितना चार्ज है? 3 पॉजिटिव ट्वाइस मतलब 6 पॉजिटिव. यहाँ पे कितना चार्ज है? 14 पॉजिटिव एंड 2 माइनस, यानी यहाँ पे यू हैव 12 पॉजिटिव. तो इधर 12 पॉजिटिव, इधर 6 पॉजिटिव, मीन्स यू नीड टू ऐड 6 इलेक्ट्रॉन्स. सो इफ यू आर आस्क्ड गिव एन इक्वेशन टू शो दैट पोटेशियम डाइक्रोमेट इज एन ऑक्सीडाइजिंग एजेंट, यू कैन गिव दिस इक्वेशन. इस इक्वेशन का E0 वैल्यू इज 1.33 volts का मतलब दिस रिडक्शन इज अ पॉजिटिव वैल्यू, which means the reduction will happen. So your dichromate quickly transforms into chromium ions in acidic medium by accepting 6 electrons. Now if you are asked to give an example of a complete equation, what you can do is you can couple this particular equation with iodide transforming to I2. Balance it up, इसको twice कर दो. You will require 2 electrons here, but 6 को cancel करना है, so multiply this equation by how much? इसको मल्टीप्लाई करने के लिए यू नीड टू मल्टीप्लाई इट बाय 3. सो दिस बिकम्स 6I minus 3I2 plus 6 इलेक्ट्रॉन्स. तो ये वाला इक्वेशन और ये वाला इक्वेशन दोनों को ऐड करके यू कैन गेट योर नेट रिएक्शन विच विल प्रूव दैट येस पोटेशियम डाइक्रोमेट कैन एक्ट एज एन ऑक्सीडाइजिंग एजेंट. दिस इक्वेशन एंड दिस इक्वेशन, इसको ऐड कर दो, इलेक्ट्रॉन्स कैंसिल हो जाएंगे. और एल्स you can also transform ferrous goes to ferric plus an electron here multiplied by 6 कर देते हैं. 6, 6 and 6. You can use this equation along with this. इन दोनों को ऐड कर दो. You will again get a net equation to show that yes, potassium dichromate is acting as an oxidizing agent. Fine. In both the cases you are using acidic medium. Moving on to the second important compound, potassium permanganate. पर्पल कलर का है और आप टाइट्रेशन में इसको यूज करते हैं. I'll be moving on with the lab preparation. To prepare potassium dichromate, we use MnO2, that is manganese dioxide, KOH and oxygen. Again, it is a fusion reaction, मतलब no water, only heating it directly. When you heat it directly, it gives you potassium manganate plus water. After that, to this manganate ion, this manganate ion is green in color. If you acidify it, it transforms into permanganate and MnO2 plus 2 water molecules. इस reaction पे focus करते हैं. Let us find out the oxidation number of manganese in all the identities having Mn. इसमें Mn का oxidation number अगर आप निकालोगे, you will come out to be 6. इसमें Mn का ऑक्सीडेशन नंबर इज +7, इसमें इट इज +4. नाउ कैन यू सी Mn इज ट्रांसफॉर्मिंग टू +7, यानी देयर इज एन इंक्रीज इन ऑक्सीडेशन नंबर, मतलब ऑक्सीडेशन हो रहा है. Mn इज ट्रांसफॉर्मिंग टू Mn फ्रॉम MnO4 2 minus to MnO2. योर Mn इज गोइंग फ्रॉम +6 to +4. इस बार डिक्रीज इन ऑक्सीडेशन नंबर हो रहा है, मतलब रिडक्शन हो रहा है, विच मीन्स द सेम एलिमेंट इज अंडरगोइंग ऑक्सीडेशन as well as reduction. Such a reaction is known as disproportionation reaction. And that can be understood. Mn is transforming from +6 to +7, that's oxidation, and from +6 to +4, that's reduction. So this is one example of disproportionation reaction. बेटा ये वाली preparation lab preparation है. इसमें एक drawback है. You do not get pure purple color का permanganate. उसमें ये impurity is what you will always get. MnO2 का impurity मिलेगा when you prepare it in the lab. So we need a better method where you can get pure amount of potassium permanganate, and this impurity should not be there. For that we use a commercial method of preparation. In this commercial method of preparation we use, this is the ore of manganese called as pyrolusite. This pyrolusite is oxidized by using oxidizing agent or air in the basic medium, gives you manganate which is green in color, which is then made to undergo only oxidation. Electrolytic, using electricity only oxidation can only give you the purple colored potassium permanganate, where the oxidation state is +7, goes from +6 to +7. ये reduction वाला part नहीं होता है उसमें, only oxidation, because you are doing it forcefully by using electric current. Of course, this is a commercial method. MnO2 is a brown colored salt. It transforms into green, it transforms into purple, which means kabhi koi question brown black going to green going to purple eye, so you should understand it is regarding this potassium permanganate only. Fine? Clear? Alright, let's talk about KMnO4, some important properties which will be of use to you during your viva in titration. Your KMnO4 has a low solubility. Only 6.4 grams of it dissolves in 100 grams of water. That is why whenever you have your titration, KMnO4 is to be prepared much in advance. क्योंकि अगर उस समय बनाने बैठेंगे तो dissolution ही नहीं है. It takes a lot of time to dissolve KMnO4 into water. Thermal decomposition. You cannot dissolve KMnO4 into hot water because it will undergo decomposition. मतलब टूट जाएगा. Your purple colored KMnO4 को heat करो तो it gives you green colored manganate ion, brown colored MnO2 and oxygen gas is evolved. So heating is not advised on KMnO4. If you remember, जब हम titration करते हैं oxalic acid versus KMnO4, heating हम oxalic acid की करते हैं. KMnO4 को थोड़ी कभी heat करते हैं because it will undergo decomposition. Also your purple colored KMnO4 को heat करो तो वो permanganate ion transforms into manganate ion, and this is diamagnetic, this is paramagnetic. It has unpaired electron, one unpaired electron. That is why we say there is a magnetic property which is also affected. Your diamagnetic substance changes into paramagnetic substance by heating it. There is one unpaired electron. Now there is a special compound S2OH2 minus ion. This S2OH2 minus ion is your peroxo disulfate ion. This is obtained from the Marshall's acid. What is so special about it? This is a much stronger oxidizing agent than KMnO4. Have a look. Mn is going from +2 to +7. मतलब Marshall's acid का ये component is capable of oxidizing Mn2 positive to Mn7 positive. It is much more a stronger oxidizing agent as compared to your KMnO4 also. So is able to oxidize Mn2 positive into purple colored MnO4 minus. So that's an important property of this particular acid. Fine. Now KMnO4 acts as an oxidizing agent. Have a look at these three equations. 1, 2 and 3. Can you say what is common in the three equations? The common identity is electron gain. One electron is gained, your purple changes to green. 3 electrons are gained, your purple changes to brown. 5 electrons are gained, your purple changes to colorless. And this is what we do in our titration. एक इलेक्ट्रॉन गेन करेगा तो ग्रीन बनेगा, 3 इलेक्ट्रॉन्स गेन करेगा तो ब्राउन बनेगा, 5 इलेक्ट्रॉन्स गेन करेगा तो कलरलेस बनेगा. and we want this to happen for our titration to be done. That is the reason we require a large amount of acidic medium. That is the reason we add a test tube full of dilute sulfuric acid during the titration. In all the three, the value of E0 is positive. इसका मतलब reduction is going to take place. Reduction तो होगा. All of them will definitely gain electrons. But you want it to gain maximum electrons. For this you require a highly acidic medium, and that's the reason you add one test tube full of dilute sulfuric acid. Have you ever noticed कि brown बनता है कई बार during titration? उसका reason क्या है? Highest E0 value तो इस reaction की है. Highest E0 का मतलब this is a preferred reaction, which means given a choice, your MnO4 minus will prefer to transform into MnO2 according to the E0 value. But अगर acidic medium थोड़ा सा भी कम रह गया, मतलब acid weak रह गया, आपने तो one test tube डाला है but acid की concentration कम थी, तो ये brown जल्दी बन जाता है. Also during titration, as you keep adding your KMnO4, आपका reaction होता चला जाता है and acid is used up. तो ओवर अ पीरियड ऑफ टाइम कई बार थोड़ी देर के बाद ब्राउन आना शुरू हो जाता है, विच इज़ एन इंडिकेशन द मीडियम इज नॉट एज एसिडिक एज यू रिक्वायर, विच मीन्स आपने तो वन टेस्ट ट्यूब डाला है बट जो एसिड आपकी शेल्फ पे पड़ा है उसकी स्ट्रेंथ 2 मोलर से कम है. फाइन. सो यू शुड नो कि पार्शियल रिडक्शन अगर होगा तो इट कैन ट्रांसफॉर्म टू ग्रीन, थोड़ा ज़्यादा रिडक्शन तो ब्राउन, maximum reduction to colorless, and this is what we want, and that's the reason we use the one test tube full of dilute sulfuric acid. Alright, quickly going on to the redox titration of class 12th. Mohor salt का titration versus KMnO4 है and it is to be done in acidic medium. You use your, I'll just change this, you use your MnO4 minus and highly acidic medium and you want it to go to Mn2 plus. For this, let us balance this first. Oxygen are to be balanced by water. So 4H2O. Hydrogen is to be balanced by H positive. So 8H positive. Charge is to be balanced by electrons. -1, 8 positive. यानी 7 positive रह गया. यहाँ पे 2 positive है. 7 positive and 2 positive, which means you need to balance the charge by adding 5 electrons on this side. So this is your reaction of reduction which happens during your titration. इतने बड़ा मोहर सॉल्ट का फॉर्मूला याद है आपको? FeSO4, अमोनियम सल्फेट, 6H2, ferrous ammonium sulfate, hexahydrate. Your interest is only in ferrous. Titration में your ferrous changes into ferric and there is a gain of electron. जब इनको ऐड करना होता है, you multiply this by 5 the whole equation and you add the 2 to get your resultant equation for titration. This part you can do it on your own, or else you can refer to my videos on titration to get more clarity on the titration of Mohor salt versus KMnO4. This is provided by one test tube full of dilute sulfuric acid and this is colorless, which is your requirement for the titration. Second titration oxalic acid versus KMnO4 है. Oxalic acid versus KMnO4 में first equation तो as it is रहता है. The second equation has your oxalate ions from the oxalic acid. These oxalate ions transform into CO2. तो पहले कार्बन को बैलेंस करेंगे, ट्वाइस कर दो. ऑक्सीजन 4 here it is already balanced. चार्ज को बैलेंस, हाइड्रोजन है ही नहीं, चार्ज को बैलेंस करने के लिए you require 2 electrons here. Now if you want to add the 2, this is to be multiplied by 2 ताकि electrons 10 हो जाएंगे. This is to be multiplied by 5 ताकि electrons 10 हो जाएंगे. And then you can cancel electrons, बाकी सब कुछ into 2 हो जाएगा इसमें, into 5 हो जाएगा and you will get your net reaction. Now this reaction happens at 60 to 70 degrees temperature and your Mn2 positive is important in this because it acts as autocatalyst. मतलब ये जैसे जैसे बनता जाता है रिएक्शन में वैसे वैसे रिएक्शन फास्ट हो जाता है. इसीलिए ऑक्सैलिक एसिड वर्सेस KMnO4 की टाइट्रेशन में यू रिक्वायर टू हीट इट बिकॉज इट इज़ अ स्लो रिएक्शन एंड सेकेंडली इनिशियल ऐड ड्रॉप वाइज KMnO4 ताकि ये बन जाए. ये बन जाएगा तो रिएक्शन अपने आप फास्ट हो जाएगा. यू डू नॉट नीड टू हीट इट कंटिन्यूसली. एक बार हीट कर दिया, रिएक्शन स्टार्ट हो गया, ये बन गया तो रिएक्शन अपने आप आगे चला जाएगा. If you still have your doubts on titration, you can refer to the playlist on Redox titration on my channel by Seema Makijani, and you will reach all your doubts about the titrations will be cleared. Viva questions are also on that particular playlist. With this, I come to the end of the second part of the D and F block of elements, and I am left with only the first part, in which I will deal with the 10 to 12 properties of D block of elements, which we will be doing in the next video. Fine. Hope you have understood this part of the chapter. Keep watching the channel. Stay happy, stay blessed, stay safe. Bye.